All right, today we're going to be doing lecture 12, two-step equations. So we did one-step equations, which just required adding, subtracting, multiplying, or dividing. And today we're going to bump it up a notch. We're going to be doing two-step equations. So let's start off with one that should be very familiar to you from the classwork. 5p plus 1 is equal to negative 14. So for this equation, I have two terms on the left side and I have one term on the right side. What I always want to do is I want to isolate the variable. I want to figure out what p is. So in front of p, I will put a question mark because we don't know what it is yet, but I do know that I want to isolate the variable. Isolate the variable, p. So how can we do that? How can we get p by itself? The first thing that we have to do is get rid of the plus 1 out here. That's going to be the first thing that we get rid of. The second thing that we're going to get rid of is the 5 that's out in front of the p. We need to get rid of that too. So the plus 1, we can get rid of that by subtracting 1 from both sides. I see a plus 1, so I'm going to do a minus 1. And when I do that, the plus 1 and the minus 1 are going to cancel out. So I can cross them out. On the left side, I'm only left with 5p, so I have to bring that down. And then on the other side, I have negative 14 minus 1, and that's going to give me a negative 15. So now I'm in a situation where I only have 5p is equal to negative 15. Now I just need to get rid of the 5 that's out in front. And the way I'm going to do that is by doing the opposite of what you see. You see 5 times p, so I'm going to divide everything by 5. I'm going to divide both sides by 5. So I draw my fraction bars, and now I'm getting ready to cancel out the 5s on the left side. So I can cancel out those 5s because 5 divided by 5 is just going to give me 1. So p is going to be the only thing that comes out from the left side. On the right side, I have all the numbers there. I have negative 15 divided by 5. That's going to give me negative 3. So that's going to be my answer, negative 3. So what I'm going to do with this negative 3 is put it inside of a solution set. I put it inside of a solution set. So we only put the answers inside of the solution set. So I'll write beside that solution set. Okay, so now we know what the answer is. The last thing that we need to do is check this equation. So I'm going to change my color to yellow, and I'll kind of draw a box over here. Hopefully that'll separate some things out. And I can do my checking inside of the box. Okay. So I write the word check. That's how I started off. And when I check, I always start off with my original equation. I want the original equation because that's what we're solving for. We're taking that original equation, 5p plus 1, and we still have it equal to negative 14. So we get the equation that we started off with. The next thing I'm going to do is I'm going to let p be my answer. So my answer was negative 3. So I'm going to replace the variable p with a negative 3 and see what happens. So I have 5 times negative 3 plus 1 is equal to negative 14. And from there, I just make sure that the left side is equal to the right side. The first thing I can do is I can multiply 5 times negative 3. That's going to give me negative 15. But I still have that plus 1, and it's still set equal to negative 14. I've got to remember that because I'm trying to make the left side equal to the right side. So the last thing I do is I do negative 15 plus 1. That's going to give me negative 14. So I get negative 14 is equal to negative 14. That is true. So I write true down and I put a check mark. So that's what you have to do to check your answer. You have to start off with the original equation that they gave you. And then you're just testing to make sure that negative 3 actually belongs in the solution set or not. That's what you're trying to figure out. So we have a 3-step process here that we're working with. The first step is to isolate the variable. So I'll put a 1 in front of the isolate because we're really trying to get p by itself on the left side. And I do 2 steps to get there. And then once I get to my answer, I do the second step, which is to create a solution set. So I'm going to put a 2 beside the solution set. So I'm going to be looking for your work in step 1, your solution set in step 2, and then your check is the last thing you do. So I'll put a 3 beside that. So those 3 things are going to be required. Okay. So that is number 1. The next thing I want to do is I'm actually going to jump to number 10. I'm going to jump to number 10 because I like this question. And I think it's going to help a lot of people. Okay, so this is number 10. 1 equals b over 5 plus 3. I want to do a 3-step process. So I want to isolate the variable. That's the first thing I want to do. The second thing I want to do is I want to do a solution set. And then the third step is to check my answer. So to get the b by itself on the right side, I need to get rid of 2 things. I need to get rid of the plus 3 first. I can do that by subtracting 3 from both sides. But you do have to do it on both sides of the equal sign for this to work out. So the 3 and the negative 3 are going to cancel each other out because 3 minus 3 is just going to give me 0. And I can ignore that for now. I bring down the b over 5. And it's going to be equal to whatever I get on the left side. 1 minus 3, that's going to give us negative 2. Okay, so the last thing I need to get rid of to get b by itself has to be this 5 in the denominator. And notice I'm dividing b by 5. So I do the opposite of division to get rid of the 5. And the opposite of division is multiplication. I'm going to multiply both sides by 5. So I put a 5 in parentheses next to the fraction, and then I put the negative 2 in parentheses as well because I'm about to multiply it by 5, right? Okay, so we're multiplying both sides by 5. The 5s are going to cancel out on the right side, leaving me with a b is equal to what? 5 times negative 2. That's going to give me negative 10. So that's what's going to be inside of my solution set, negative 10. Okay, so let's go ahead and check our answer. And I'm going to do that on the right side. Okay, So to check our work, I always start off with the original equation that they give us. 1 equals b over 5 plus 3. I always start off with the original because we're trying to figure out what the variable is. Since we know that b is equal to -10, I'm going to see if that works by plugging it in for b. So instead of having a b on the top, I'm going to have a -10 on the top of the fraction. All right, so I put in -10. There are two things that I need to do. I need to divide by 5, and I need to add 3 at the end. So what's -10 divided by 5? That's going to be a -2. And I bring down the plus 3. And now if I add 3 to -2, I get +1. So I get 1 is equal to 1. That is a true statement. So I know that -10 is actually going to work here, and it belongs in the solution set. Okay. Now let's go back to number 6. So number 6 is kind of like the last one, but the steps are done in a different order. So I'm going to have p minus 6 on top of the fraction, and I'm going to have a 10 in the denominator. And everything is set equal to -2. So basically what I want to do is I want to do a 3-step process. I want to isolate the variable. I want to do a solution set. And then the last thing I want to do is I want to check my work. Now I need to isolate the variable. In this case, it's a p. I want to get it by itself on the left side. That means I get to get rid of two things, a -6 and a 10 in the denominator. I'm going to get rid of that 10 first. That's the first thing I need to get rid of, because I can get rid of that 10 in the denominator by multiplying both sides by 10. Then after that, I can tackle the -6 and get rid of that. So let's do that. We need to get rid of the 10 first. So the way I'm going to do that is by multiplying both sides by 10. So that way, the 10 and the 10 will cancel each other out. On the other side, I still have a -2, and I'm multiplying this side by 10 as well. So when I do that, the p minus 6 is going to come down, and I have -2 times 10, which is -20. So now I just need to get rid of the -6, and everything would be good, right? So to get -6, we need to add 6 to both sides. We need to add 6 to both sides. That is the opposite of a -6. Now the good news is that the -6 and the +6 will cancel out. So now the only thing left on the left side is going to be a variable. The only thing left on the right side is going to be -20 plus 6. That's going to give me -14. So that's going to be the number inside of my solution set, -14. The last thing that I want to do is I want to check all my work. So let me draw a box to do my check-in. You could just do this on the right side of your paper if that works for you, just as long as you are checking your work. So I'm going to start off with the original equation. And I'm going to let the variable be negative 14 and see what happens. So what do I get? Negative 14 minus 6 over 10 is equal to negative 2. On top of the fraction, I can simplify that a little bit further. Negative 14 minus 6 is going to give me negative 20. And since I'm dividing by 10, that's what's going to give me that negative 2 on the right side. So it all works out. That is our true statement. So negative 14 definitely belongs in the solution set for this one. But notice how we did that in 2 steps. We got rid of the 10 first, and then we got rid of the negative 6. The reason why we got rid of the 10 first is because the 10 was trapping the negative 6 with the variable. So there's a 2-step process, right? But you really got to consider which order you're going to do things. And that'll just become apparent through the problem that you're doing. Okay. The last one that I want to do today is number 5. So let's try that one. Number 5 says 3 times r plus 1 is equal to 42. So this is the equation that they start us off with. Notice that you have something in parentheses and you have something that's on the outside of the parentheses. We are essentially multiplying everything by 3. So to get r by itself, what I need to do is first isolate the variable, get r by itself. It is a 2-step process. I need to get rid of whatever is not the variable, right? That's just the best way I can put that. We need to get rid of this 3 right here, and we need to get rid of the plus 1 right here. So how can we do that? Well, if we want to get rid of the 3 first, what we could do is we could divide both sides by 3. That way, the 3's will actually cancel each other out on the left side, because you have a 3 on top and you have a 3 on the bottom, and 3 divided by 3 is just going to give you 1. And multiplying by 1 changes nothing. On the right side, I have 42 divided by 3. 42 divided by 3, that's going to give me what? 14? What am I left with on the other side, though? I'm only left with an r plus 1 on top. So I get r plus 1 is equal to 14. Now I can get rid of the plus 1 by subtracting 1 from both sides. That way, the r will be by itself on the left side. (14 minus 1), that's going to give me 13. And those ones cancel. So I've got 13. I'm going to do the second thing I need to do, writing a solution set. My solution set. It is a singleton set. That means it only has one number inside of it, 13. And the last thing I need to do is I need to check and make sure that 13 actually works. So let's do that. Okay, so I always start off with the original equation. I always start off with that original. 3 times r plus 1 is equal to 42. I know that my solution should be 13. So I'm going to let r be 13. But everything else is going to stay the same. So now I have 3 times 13 plus 1 is equal to 42. Well, what's 13 plus 1? That's going to give me 14. And now I have 3 times 14 on the left side. That's going to give me 42. So that gives me 42 equals 42. That is my true statement. So 13 is actually going to work for R. Okay. Now, there is a second way that you can do this. And it's not a two-step process, but it does involve the distributive property. So let's take another look at number 5. And I'm going to do that on the next slide. Okay. So another way you can do this one, and I'm just going to write out the original equation first. 3 times R plus 1 equals 42. You can actually use the distributive property to help you out with this. So I will write distributive property. Basically what that means is you've got something on the outside, in this case it's a 3, and I need to distribute that 3 to everything on the inside of the parentheses. So I'm going to be multiplying 3 by R, and I'm also going to be multiplying the 3 by the 1. So let's do that. When I multiply 3 by R, I get 3R. And the plus sign comes down. I have 3 times 1, which is 3. And then this side is still 42. Notice that I have a 3-step equation now. I'm sorry, a 2-step equation. I have a 2-step equation because I can figure this out by getting rid of the plus 3 and the multiply by 3. Now it's a 2-step process. I can get rid of the plus 3 by subtracting. 42 minus 3 is going to give me 39. On the other side, the 3 and the minus 3 cancel each other out. And I bring down my 3R. Now to get rid of this 3, since it's being multiplied by R, I need to do the opposite. I need to divide both sides by 3. So that way, the 3 in the numerator cancels out with the 3 in the denominator. And I'm left with R is equal to 13. I put that in my solution set. And then the last thing I do is I check my answer, which I already did on the last slide. So I'm going to say that check did indeed give me that true statement that I needed. Okay, so that is just another way that you can do number 5. And we're doing it this way by the distributive property. So that is something that's very special about 5 that's not true about the other ones. Okay, so I'm going to go ahead and stop it right here.